In this problem from mechanics, it has been given that there is an inclined plane, but the surface of the inclined plane is divided into two parts. The part from B to C is smooth, and the part from C to A, that is rough, and the coefficient of kinetic friction is given by this relation, which is mu is equal to k tan theta. Now the total length of the inclined plane is not given, but it has been mentioned that the portion BC is equal to 2 times of AC. That is, the smooth portion is 2 times the rough portion. Now an object is starting from rest from this point B, and it starts falling down. It is observed that when this object reaches A, its final velocity becomes equal to 0. So what you have to do is you have to find out what is the value of this K. This is actually a simple problem, but let me tell you that this problem can be solved in two ways, by two methods. And I would be showing you both the methods. The first method is the method using force diagram, accelerations, etc. The second method is by the principles of energy conservation. Now remember that this method 2 is the easier method or the shorter method. The method 1 would take some more time, but I would like to delve upon both the methods so that it gives you some amount of confidence and understanding of how this is done. So what is happening over here? Let's solve this by the force method, okay? Let's start with the force method. See, in this portion of B to C, that is the movement on the smooth portion, what is the free body diagram of this object? So this is the object. I'm looking at the object from a fixed reference frame or an inertial reference frame, let's say from outside, okay? So there would be no pseudo force, and the forces would be mg downwards. There would be a normal reaction force. This angle would be theta, and there is no other force. But this object would be having an acceleration downwards. Let's call this acceleration as A. And from here, you can see that mg sine theta is equal to ma. Hence, A is equal to g sine theta. Now, the object starts with a 0 velocity because it is starting from rest. Hence, find out what would be the velocity at the point C. So for that, let's assume that the length of AB is equal to L. That means BC is equal to twice L by 3 and AC is equal to L by 3. Okay, very simple mathematical calculations. So that means for this movement from B to C, the object covers a distance of twice L by 3. Now we use the third equation of motion to find out what is the velocity at the point C. Let's call that as V. So V square must be equal to twice of this acceleration times the distance. Put the values, twice g sine theta into twice L by 3. Let's keep this in hand, okay? Let's get into the next portion of the motion, which is from C to A. So for the movement from C to A, the initial velocity is nothing but the final velocity in the movement from B to C. But the free body diagram of the object would change because there is friction. How would the free body diagram look like? The weight is still acting. The normal reaction force is still there. The angle is still the same, but there is a friction at the bottom of the surface which is acting upwards. Okay, the friction's direction is upwards. Also, you should understand one thing. See, if the object is to come to rest at this point, that means the net force must be acting upwards, and the acceleration of the object in this portion of the motion must be upwards. That is, the object is decelerating here on. So let's now write down the force equations. So in the upward direction, the net force would be this frictional force minus mg sine theta. That must be equal to the mass of the object times acceleration. And we must also have n is equal to mg cos theta. Now we know that in case of kinetic friction, the frictional force magnitude is equal to mu times n. So I can write frictional force is equal to mu mg cos theta. I'm not substituting the value of mu as of now. I put this over here. What I get is m a dash is equal to mu mg cos theta minus mg of sine theta. Hence, the acceleration or the deceleration, whatever way you call it, during the movement from C to A is equal to mu g cos theta minus g sine theta. Now, again use the third equation of motion in this portion. So the final velocity is 0. The initial velocity is that v squared that we had found out minus twice a dash into d, or let's say d dash. We know everything. We know the v square. The v square is 2g sine theta into twice L by 3. I can write this as 4lg sine theta by 3. 4lg sine theta by 3 minus twice g mu cos theta minus sine theta. This is the acceleration value, minus twice g mu cos theta minus sine theta into the distance. The distance is L by 3. See this L, it cancels out. This g cancels out. The 3 cancels out. And you are left with, I can write this as 4 sine theta is equal to twice mu cos theta minus twice sine theta. And from here I get 6 sine theta is equal to twice mu cos theta. Hence, finally I have got mu is equal to thrice tan theta. Now, you are told that mu is equal to k tan theta. Clearly from here you see that k is equal to 3. So this is the answer. But the method that I have followed over here is much lengthier. It took a lot of time. This can be solved in a much simpler way if we use the concepts of energy. See, the total energy at this topmost point must be equal to the final energy at the point A, add to it the work done or the dissipative work done. So what is the total energy at point B? Let me write this as total energy at point B is equal to the potential energy of point B at that point. And what is the potential energy? That must be equal to the mass of the object, g, times the height. So the inclined plane is like this. Let's assume again that the length of the inclined plane is L. This angle is theta. That means the height over here is L sine theta. So I can write this as mg L sine theta. So that is the total energy. Now, my reference point or reference line for calculating this energy is, of course, the ground. And at the bottom, the total energy at bottom, that is equal to 0 because there is no kinetic energy at this point. There is no potential energy. So that means this entire initial energy is lost in doing the dissipative work against the friction. Now, what is the dissipative work? The dissipative work must be equal to, let's write this as W. that must be equal to the frictional force multiplied by the distance that was moved along the rough surface. Now, what is the distance moved? The distance moved is L by 3. And what is the frictional force? The frictional force, it is clearly seen from here. You can once again draw the free body diagram, but the amount of work done in this can be easily found. So you can simply write the frictional force as mu mg cos theta. So put that mu mg cos theta over here, mu mg cos theta. So this mu mg cos theta must be equal to the initial total energy. If you put that, mg L sin theta is equal to mu mg cos theta into L by 3. mg cancels out, L cancels out, and I'm left with mu is equal to 3 sin theta by cos theta, which is tan theta. Hence, once again, I get k is equal to 3, the answer. But this answer is much simpler, much shorter process, okay? So this is done. This is also a moderately simple to moderately difficult problem. Okay, thank you.